this is our video. This is section 3 of Unit 8, Accumulation, Functions, and Context. So this is not actually anything new. We have done many of these things. This is just sort of a kind of a review and combination of all the different times where we've used this idea. So one thing, of course, we've done is we've taken velocity of an object and we integrate it to get an amount, but we can do that on anything. So we've talked about that before. If you have gallons per minute and you integrate it, you get gallons, etc. So that kind of idea about accumulation. All right, so here we have a scenario where we have a 10-week Basset Hound puppy and discovered he's gaining weight at a rate of e to the whatever pounds per week, where t is the puppy's age in weeks. At 10 weeks, the puppy initially weighed 14 pounds. What is the expected weight of your new puppy at the end of week 15? So again, important things here. The equation that you're given, e to the 0.0125t, is in pounds per week. If we integrate it, we're going to get pounds. Well, that's what I'm trying to find, is what is the puppy's weight. So I want pounds. So I want pounds at the end of week 15. So basically, I'm going to just take my initial value of 14 pounds, and I'm going to add, I'm going to integrate from 10 to 15 of this equation that gives me the weight pounds per week of growth, and that's going to give me pounds. So when I integrate from 10 to 15, I get the accumulated, the weight from weeks 10 to 15. I add that to the 14 that I started with, and this is going to give me my final answer. So obviously calculator question. So 14 plus, and then when I do this in the calculator, I get this. And so I'm going to say approximately 19.846 pounds. And then you should always write, always be in the practice of saying, we expect the puppy to weigh about 19.846 pounds at the end of week 15, or when he's 15 weeks old, or something about that. But just get in the habit of always answering that, because especially if you're supposed to round something to the nearest whatever, this is your time to do that. Okay, so example 2. So now we have a monorail, and it's slowing down at the rate of 2t plus 25 feet per second, where t is time in seconds. By how many feet per second does it slow down between 1 and 5? Okay, so it's feet per second, so if we integrate it, we'll have feet per second. So here we have no initial value. We just want to know what's happening between 1 and 5 seconds. So if we integrate feet per second, then we will get the total feet per second that it is slowing down. And that's, again, accumulation questions. So this would be one you would do without a calculator generally. Of course, these examples aren't really split like that, but you can start to see, you should kind of understand when you see one that would be a calculator question and versus I should practice this by hand. So we would plug in 5. We would get 25 plus 25 times 5 is 125 minus parentheses 1 plus 25. I just plug in 1. So this is very simple because 25 minus 25 will go away. 125 minus 1 is 124. And then I need to have my units. And then better thing to write and get in the habit of is to say the monorail slows down at about 124 feet per second between t equals 1 and t equals 5 seconds. Okay, so you should practice that on every question, writing out that sentence, especially if you have not been and you're struggling on that. Okay, let's look at example 3. So example 3, we have the number of liters of oil in a tank changing at a rate of 0.26 T liters per minute. Initially, they contained 14 liters of oil. Write an expression that can be used to find the amount of oil. And we had, again, units of liters per minute. So if we integrate liters per minute, we're going to get liters. So the one thing that happens the most often, okay, where students mess up is they forget this initial condition. So it's the initial condition plus the integral that's important, which is after 10 minutes, so 0 to 10 minutes, 0.26 T dt. Now notice it just said write an expression that can be used. It did not tell me to find the answer. So you certainly can practice and you could go ahead and find the answer, but it didn't ask for that. It said write an expression that can be used to find the amount. Okay? So you're welcome to practice that by hand, then put it in a calculator and check your answer, whatever you want to do there, but also it's important that we do what the problem says and don't overdo, because this could be right, you could mess up the next part and lose all the points when in fact you have the right thing. Okay, so interpreting expressions. So now we're just going to go the other way, where they're going to give us the scenario, they're going to give us an integral of some kind, and then we need to say, what does that mean? Okay, so this is also important and happens a lot on free response questions. They're going to say, explain what this means or interpret the meaning of this integral. Okay, so part A here, we have the function WT gives the number of water bottles produced by a manufacturer at time t on any given day. Explain the meaning of the expression, integral from 4 to 8 of W prime t dt. So W prime would be water bottles per day, or per hour, I guess. We would have units there. That's a rate of change in water bottles per hour. So if we integrate that, we're going to get total water bottles, okay? But be cautious, because remember on our interpretation, we've talked about this over and over, I've got to give the right units. So what am I finding, and when, or over what interval, okay? So this would be the number, or you could say the total number, as long as you say the right thing here. Oh, sorry, the number of water bottles produced, because that's what they told me WT was, number of water bottles produced during the 4th and 8th hours. Now you could also say from hours 4 to 8. You could say during the hours, something like that. As long as you say it's only at this time, okay? Because what's happening at different times of day is not the same thing, but what's happening between the 4th and 8th hours is what this integral will tell me. All right, part B. So now we have oil drained from a pickup. It's decreasing at a rate of R of T quarts per minute. Quarts per minute is what R of T is in. Time is T is in minutes. What does the expression below mean? So if I integrate from 3 to 4 of R of T, so if I integrate quarts per minute, I'm going to get quarts. So this is going to be the amount of oil, because it tells me that R is it draining. Okay, so this is the amount of oil drained from the 3 to 4 minutes, between 3 and 4 minutes, is negative, or it's being decreased by half a quart, or the rate is negative 0.5 quarts, something like that. Okay, so let's write that out. So we could say during the time t equals 3 to t equals 4 minutes, the amount of oil drained from the truck, So again, that's what they told me it was. They said this is the amount of oil being drained from your truck. Okay, so the amount of oil drained from the truck. The answer is given, so we would say it decreased by half a quart. So use decrease and don't put negative, because that's what a negative rate means. Okay, so it decreased by half a quart. That's what happened. Or not a rate, but a negative amount for that means that the amount of oil being drained is the amount of oil being drained decreased by half a quart because of the negative. Okay, so C, we have a person, Kevin, getting a gift of $500 from his parents for graduation. He deposited into his college savings account. His savings account grows at a rate of R of T, hundreds of dollars each month. This is important. Hundreds of dollars each month. T is the month of the year. Okay, that's important. T is the month of the year. What does the expression below mean? So, a couple of things here that would get people confused that you got to remember is 500 is represented by 5 because the number's in hundreds of dollars. So there's your initial value, so that's what the 5 means. And then we're integrating from 1 to 12. Well, if the time are the months of the year, then that means over a year. So after 12 months, and you're integrating his rate in hundreds of dollars per month. So if you integrate it, you get hundreds of dollars. And then the answer is 24, which is $2,400. So basically we would say by the end of the 12th month, or you could say after 12 months, because again, you always have to say, when are we talking about? What's the interval here? And you would say Kevin's account, because that's what all of this represents. This represents the money in his account. So 5 is the initial, and then 1 to 12 represents all of the money he's earning from that time. So this is Kevin's account, had a total of, and this is where you have to be careful, it's not $24, it's $2,400 in the accounts. Now, another thing I want to mention, because this keeps happening, I have a lot of you that for some reason want to write 2,400 and then a $sign afterwards. That's wrong. So just don't do it. If you want to not put a $sign in front of the amount for some reason, then you have to write the word dollars. So please don't get in bad habits. It's not 2,400 and a $sign after. That's not how we write money. So you either write $2,400 correctly, like this is, or write the word 2,400 and then write the word dollars. But do not put a $sign afterwards, because that's not right. Okay, here's a table problem, an example of kind of looking at how we could approximate velocity using this table. So this table is acceleration, okay, in feet per second squared. And the bus is accelerating from 0 to 18 seconds. Here's the record of what we're doing. If the velocity at t equals 0 is 6 feet per second, so you have an initial amount, really important. That's the thing that most people end up missing. Find the approximate velocity at t equals 18 using a trapezoidal sum. So the velocity at 18, and this is where several of you had some problems on a test. So it's not, the velocity at 18 is not to integrate and just find the velocity over 0 to 18. It includes the initial velocity plus the integral from 0 to 18 of a of t dt. Okay? So it's going to be approximately, because now I'm going to approximate it, the initial velocity, which they told me was 6, plus they told me to use a trapezoidal sum here. So every interval, again, good idea to sort of, especially if you have trouble, kind of write these bars there. Notice that every interval is 3. So the height of every trapezoid will be 3. So we can put 1/2 times 3, and then inside the parentheses, base plus base plus base plus base, and just keep doing that. So you can memorize a formula, or you can just do it this way. So I would just say 1 plus 4 plus 4 plus 6 plus 6 plus 8 plus 8 plus 7 plus 7 plus 9 plus 9 plus 10. And then close your bracket. Now, if this was a free response test, you're done. You would leave that answer. If you happen to notice the pattern that there's always going to be the beginning number and the end number and 2 of every number in between, you can write it out that way. On an AP test, I would suggest writing it like this, and then I'm done. Now, you should practice, because sometimes it's going to be on multiple choice. You're going to have to actually be able to add it. So it's not going to hurt you to practice and see that the answer is 124.5, and then make sure you have units. So if you were going to stop at the answer above, be sure you had some units at the end. Okay, so again, if it was free response, I definitely would stop with the answer above that. Okay, last one that we're going to do. There's one more example that we're not going to do, which is example 7. So this is our last example for this set of notes. So the graph at the right shows the rate in gallons per hour at which storm water is being pumped from an overflow canal. Find the approximate number of gallons pumped during the 24-hour period. So if I have gallons per hour and I want gallons, okay, so if I want the gallons of storm water, it will equal the integral from 0 to 24 of r of t dt. Well, I don't have an equation here, and it says approximate the number of gallons. So that means I'm going to use some sort of approximation method. Now, on the AP test, I don't think they ever are going to not tell you what approximation method to use. If you do get to choose, I would always choose trapezoid because it's more accurate, okay? So to do the trapezoid rule here, I would split them at the clear places that it appears, which would be at these marks, you know, 0, 4, 8, 12, 16, 20, and 24, because that would make the most sense. And so again, I'm just going to write out the long expression, and then you can practice adding up your numbers and so on. And those of you that need a lot of practice, because you know you mess up when we have arithmetic, I would strongly suggest doing it. So it's 1/2, and the height every time again is going to be 4, because all of these intervals are 4 apart. Now you could draw in all your trapezoids if you wanted to, but I don't really see that to be that necessary, because we know how it works. It's going to be 1/2 height times base 1 plus base 2. Well, base 1 is 100, base 2, 125, plus next base 1 and base 2, which is 125, plus that one, which is, say, I guess about 135. So we have 125 plus 135. Then we're going to do the next one, which will be 135, because it'll be this side and this side, and then that one looks to be about 130, possibly. Normally, I think on an AP test, they're going to kind of give you some of those numbers. So then the next one would be that 130 again, plus this value, which appears to be about 110. It's not quite halfway maybe, so we'll call it 110 plus, and then you'll have 110 plus the next one, which appears to be about 85, and then you'll have 85 again, plus the last one, which seems to be about 65. Okay, and again, if this was a free response question, you would be finished. You would put, it says gallons of storm water, So you could just write the word gallons at the end of this and you're good. For yourself, if you want to practice, I would practice and I would go through and add those numbers up for some of you that need the practice in addition, for when it's on a multiple choice question and you have no calculator. Okay, so because you have to be able to add it up. So practice that for those of you that need that arithmetic help. But otherwise, this is kind of a nice section because it's a little bit of review, not really a lot of new stuff, just sort of puts together a lot of these accumulation problems.